Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to homework problems. This represents the solutions for the second set of IUPAC nomenclature problems found in the IUPAC nomenclature section of your handout notes. Here you were asked to write the structural formula for the following molecules. The molecule you were given was 4-isopropyl (4-isopropyl 5-propyl decane). Now, when you're given a name of a molecule, the first thing you look for is the root name. The first part I'm interested in is this root, decane. Decane is a 10-carbon chain, so I write down 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I add the necessary substituents. At carbon 4, 1, 2, 3, 4, I have an isopropyl group, which is a CH, which has 2 CH3s off of it. And then I have a 5-propyl. A propyl group is a 3-carbon chain. Once I'm done the substituents, I now place hydrogens around carbon so that every carbon has 4 bonds. So a terminal carbon becomes a CH3. This guy has 2 carbons to it, so he only gets a CH2. He has 2 carbons attached to him, he gets a CH. It's a CH2. This carbon has 3 carbons, so he's just an H. This carbon has 3 carbons, he's just an H. H2, 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 H3. And there you have it, the structural formula of 4-isopropyl 5-propyl decane. Let's try question B. In question B, you're given the following structure. It's a little more, the following name. It's a little more extensive. You're asked to draw the structure of 6-butyl, 7 sec-butyl, 4 tert-butyl, 5 isobutyl, 5 and then a dodecane. And that's all one word, dodecane. Now, before we actually go after the structure, this gives us an interesting opportunity to check the alphabetizing. Why have we written down butyl, then sec-butyl, then tert-butyl, followed by isobutyl? What's interesting is rules for alphabetizing. B is used in butyl, but sec and tert are not because they're hyphenated prefixes. So in the butyl case, sec-butyl and tert-butyl, we have B, B, and B. Isobutyl, the iso's not hyphenated, so the iso is used in alphabetizing. Okay? So isobutyl will come after butyl, sec-butyl, and tert-butyl. Now, because butyl, butyl, and butyl are all tied, you use the sec and the tert to break the tie. That is, we use to sort out between those three the B of butyl, the S of sec, and the T of tert. But the sec and tert are only used to sort out those substituent names that are identical. That is, they're all the way butyl. So, B comes before S, which comes before T. But iso comes after the tert because I comes after B. And if you're confused about that, please come see me. Now, when asked to draw this, we follow the same pattern we did last time. We have a dodecane, and that means 12 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My 12 carbons. Off of carbon 6, I have a butyl. 1, 2, 3, 4, 5, 6. So I'm going to put a butyl here. CH2, 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 and a CH3. There is a butyl group. After carbon 7, I have a sec-butyl. A sec-butyl is this. Off of carbon 5, I have an isobutyl. An isobutyl will look like this. And off of carbon 4, I have a tert-butyl, which will look like this. And now I just add the hydrogens on my dodecane chain to make sure every carbon has 4 bonds to it. So the terminal carbon gets H3. The intervening carbons get H2. But when a carbon has 3 carbons attached to it, it only gets an H. Okay, so there you have the structure for 6-butyl, 7 sec-butyl, 4 tert-butyl, 5 isobutyl dodecane. The name given in C that you have to find the structural formula for has a side chain which has no common name apparently. Yeah, let's see if it does. We'll take a close look once we draw the structure. 5 hyphen bracket 1 1 dimethylpropyl nonane. Oops, let's fix that up. And we have the nonane here. Okay, 5,1,1-dimethylpropyl nonane. Well, once again, we take the root name, the nonane, and we know that nonane has 9 carbons, so we write down our 9 carbons. 2, 3, 4, 5, 6, 7, 8, 9. And then I have carbon 5, 1, 2, 3, 4, 5. I put my 1,1-dimethylpropyl. That is, I have a propyl, which is 3 carbons. It's numbered from the point of attachment to the main chain. So off of carbon 1, there are some methyls. And then the rest of the chain is the propyl. So indeed, this type of side chain has no common name, so the IUPAC name was used instead. And the terminal carbon needs an H3. The bridging carbons need H2 because they just have 2 carbons bound to them. We're giving every carbon 4 bonds. This carbon has 3 carbon bonds, so only needs 1 H. Watch you put the correct number of H's. Always watch that. If you put too many H's or not enough H's, you will lose marks. And there we have it. Excellent. Okay, let's draw some structural formulas for some of the following common names as well. D is a simple common name. Draw the structure for isopropyl alcohol. Isopropyl alcohol. Well, if you remember correctly, an isopropyl group is a CH3 bound to a CH, bound to a CH3. Attach an OH for the alcohol group, and there it is, isopropyl alcohol. E, n-Butyl alcohol is a common name, where the N on the butyl stands for normal, which means a straight carbon chain. And so n-Butyl alcohol is like a straight butane group with an OH, so I get a CH3. CH2, 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 and an OH, n-Butyl alcohol. F asks for isobutyl alcohol. Isobutyl groups are derived from the molecule isobutane. And so you pull an H off of alcohol. Off of one of the methyl groups of isobutane. So here we go, we pulled an H off this end and instead attached an OH there. Isobutyl alcohol. G, Sec-butyl alcohol. Sec-butyl alcohol. Sec-butyl is derived from the butane molecule, where instead of pulling a hydrogen off the end of the chain, you pulled it off one of the secondary carbons. And so this is sec-butyl alcohol. H, we want Tert-butyl, tertiary butyl alcohol. Tertiary butyl alcohol is derived from isobutane, where instead of pulling an H off one of the methyls, we pulled the H off of the tertiary carbon of isobutane and attached the OH. Hence it's called tert-butyl alcohol. I, benzyl alcohol. Unlike the name sounds, benzyl alcohol is not derived from benzene, but rather what you get when you pull an H off the methyl group of toluene. And you attach an OH in place of the hydrogen, which means we got an aromatic ring with a CH2 and an OH. Benzyl alcohol. ENJ, n-Pentyl alcohol is the common name, N meaning normal, derived from a 5-carbon chain, a pentane. N-Pentyl alcohol is a 5-carbon straight chain CH3, CH2. Five carbons, one H missing from the end, and you put an OH on. There we go. There's n-Butyl alcohol. K is draw Isobutyl Alcohol. Well, remember, Isobutyl alcohol is derived from isopentane. It's called an isopentyl group because if you count all the carbons, there's 5 carbons. It is a straight chain where you go one in from the end, okay, second carbon in from the end, and you find a single methyl off of it. So it will be like this. So here's the second carbon in from the chain. There should be a methyl extending off of it. And if you count up all the carbons, there are 5 carbons, so it becomes isopentyl, and an OH makes the alcohol. Tert-butyl alcohol is derived from isopentane, but again, as in tert-butyl, you pull the H off the tertiary carbon, and if we do that, we'll get this molecule. So here is isopentane, where we are missing a hydrogen off the tertiary carbon, and in place of it we put an alcohol. N-Butyl alcohol is derived from neopentane. The common name for the alcohol, which looks like and lastly, N-phenyl or phenyl iodide. Make sure you don't draw the alcohol. We've been going alcohol the whole time. Phenyl iodide is a benzene ring which has an iodine off of it. Okay, well there you have it. The second problem set that was found in the handout notes under Nomenclature. Write the structural formula for the following molecules, A through N. Many of them were common names. Thank you.